Good morning. I'm Steve Rafferty, the town of Falmouth's water superintendent. We're here at the Long Pond Water Treatment Plant site. In our last episode, it was August. We were pulling the building together and getting inside of it. We've been working diligently and hard. We've got about another 4 months to go before we're making nice clean water for the town out of the facility. We at this point here have energized the building with power. We've got gas hooked up and folks are inside working on putting things together. As you can see a little bit along the edge here, we're to the point we're putting fencing. We're doing some of the landscaping, although more will happen in the spring. And overall, we're good to go. Let's go inside and take a look. So we're inside the electrical room of the treatment plant. We've got the power brought onto the site a little bit around August, and then the power's come into the main switch gear, and then that power, this is a very large fuse box if you want to think of it that way, where all of the pumps and the motors and the valves that have motors on them and everything that runs this plant has got a breaker that runs it and or a VFD. When the power comes in initially, it comes to the center. We've got it set up so there's a left side and a right side. So if we have 4 pumps in one area, 2 pumps are on this side, 2 pumps are on this side. So if we ever have an issue with the electrical lines, we don't lose the plant and we keep it running. We have tags on these equipment right now. That indicates that these are powered. Griffin Electric, our subcontractor for the electrical project, has done a fabulous job, both in terms of the quality of the work and staying on top of all the wiring. This big pile right down here, these are just leftover pieces of wire. But at the far back, that cabinet that's open, that's where all the instrumentation and the low voltage wiring comes back. That's really the hub that connects the computer that runs the entire plant to all of the little instruments, the temperature gauges, the pressure gauges, the flow elements, the various things that we keep track of around the site, turbidity for the color and density of the water and things like that. With some of our motors, they're quite large, and we don't want to run them at full speed all the time. We want to ramp the motors up and down based upon the pumping rate. In order to do that, we use a technology called variable frequency drives. And so we have a series of variable frequency drives on this wall, and again on there, much like where we bring the electricity in, split left and right. And these things are all electronically controlled, so we can ramp a pump up from almost 0 speed all the way up to its full speed over time. We're back to the control and instrumentation. If the flow meter says we need more flow, the electric device communicates with the VFD. The VFD increases the frequency. The pump turns a little bit faster. Today's actually a little bit of a big day on the job site. We've been working with temporary power up until today. Today's the first day that you see the overhead lights actually turned on. All of the lighting in this plant is LEDs, very, very efficient electrical devices. Similarly, the VFDs are a device that minimizes the use of electricity. You only need as much as you need. So we're trying to be as efficient and conservative with the use of power here as we can be. Let's go walk outside and look where we're at with all the tankage and how far we've come in the last several months. Come with me. So we're now in the part of the plant where we have the tankage behind us, which is where we're going to treat everything. With me right now is Keith. He's one of the superintendents with Methuen, the general contractor. And over the last several months, Keith has been instrumental in pulling together the dissolved air flotation at this end of the plant. Keith, briefly, can you tell us what you've been putting in?
Basically what we've been putting in is all of the flocculators that you see around here. So the water goes into the flocculator tanks. We mix the chemicals.
Yep.
They dump over a weir wall into our first section of the DAF tank, where we use recycled water and air and create a floated scum where the water particles will have flocculated together and create a floated scum. and they'd float across the top, and we use the rotary skimmer to skim it off into the trough. Meanwhile, the clarified water drops to the bottom and exits the DAF system.
Excellent. Well, I don't want to hold you up too long because I know you're working on getting the filters together. We're going to go downstairs after a little bit and we'll look at the saturators, which is how they make all those bubbles of air to float all of the algae up and out. Thank you so much.
No problem.
Carry on.
Thank you.
So back in August, when we were last touring through here, we just begun to get ready to start hanging the doors. This space is pretty well finished, and as you can see, we're actually using it for storage. This is a garage area, and this is the area where the gentlemen that work in the distribution system will work out of. The backhoes and the dump trucks and everything will store here. But just to run you through quickly, we've put the doors on, we've hung the doors, we've installed the bollards which protect the doors and everything. We take a minute and look up above. Again, all the lighting's in. The red piping is the sprinkler system, and that's all installed in this area. We've pressure tested those pipes to know they work well. We've installed the motor operators for the doors. We've installed the drainage piping. We've installed the heating. And we've painted all of the walls on the interior. The only thing that's left to do is to finish off the floor, but we wait to do that at the very end after we clean the building out and get ready to go. So, as you can see, it's coming together and coming together, and we are now entering into the sort of testing and training period. You'll recall there's a raw water pump station that pumps water up to this location. Well, we've tested those pumps, we've made sure they work, and we've actually pumped water all the way up to and to the front gate of the treatment processes in this treatment plant. And over the next 2 to 3 weeks leading up through Christmas, we'll continue to test a tank at a time, and a pipe and a gate and a system at a time. And then by the time we get into January, we'll start doing what's called performance testing, where we refer to it as forward flow. We'll bring flow into the plant and go through the plant from tank to tank to tank, and we'll actually circulate the water back around to the front end so we don't waste water. But once we get through all of that, then it's time to turn the plant on for good. Let's go downstairs. There's a lot of piping, a lot of things that come together that support the tankage, and that's a little bit of interest to you folks out there, I hope, too. So we're downstairs now, and I have my hand right now on the dissolved air flotation tank. Those are the tanks up above with the saturated air where we're skimming the algae off. After the water comes out of this tank, it needs to go out to the ozone contactors, which are a separate structure in that direction outside. And then the water needs to come back from that and come over and get into the filters, which are located here. This is the piping that does that. Again, the contractor's been down here working. This is 36-inch pipe, pretty good sized pipe. It takes a certain amount of skill to line it up and put it together. It has to fit exactly. One of the things we do is we use a special type of clamp called a Victaulic coupling, which gives a small amount of flexibility. So when you put the thing together, it will line up. We've got washer down water located over here. We have air-operated valves because the way the filters run, you control how water gets in and out of them, so you can backwash them. We're going to walk around to the other side of the filter and look at all the filter piping, and I'll walk you through how we keep the filters clean on a regular basis. I'm standing in front of the other half of the dissolved air flotation thickener, which are the recycled pumps and the saturator. As you heard from Keith, there's recycled water. We take a portion of the water that comes through the DAF, we bring it back here, and these pumps pump it into the big silver tank behind us, which is a stainless steel saturator. We have 2 compressors in a room over there that pump air back into that tank, and we basically make a big fizzy pile of water, which then gets pumped back into the DAF, and those air bubbles float the algae to the surface. This whole technology, if we didn't have it, we'd have to have something 4 or 5 times the size of the DAF just to remove the algae. So we're now down in an area of the plant that we call the filter gallery. There are 4 filters in the plant, and the water comes into the filter, much like a filter you have at your house, and the water comes down through the filter, and it's a combination of a specially sized out sand, and then carbon underneath that, and then the clean water comes out of this pipe, goes down. We have a pipe under this floor that then goes to some big tanks behind us, which we call the clear well. But just like your filters at home, every once in a while the filter has to be cleaned out. So here's how we do that. We actually have another tank over here full of water, and we do what's called a backwash. But we do a backwash in combination with air. The first thing we do is we take the filter offline by closing this valve here. Then we open up this air header line and start pushing air into the water that's sitting under the filter. And that air pushes the filter up a little bit. We are measuring through our instruments here and through the instruments that are driven inside the filter bed the amount of pressure and the amount of air that's saturating into the bed. And then we bring a lot of water over at once down this big pipe. We put it underneath the entire filter, and it washes upward, carrying all the dirt and any sediment that's been collected out. And then that overflows out and comes back a waste line. And that waste line then goes to a separate tank, and then we recycle that water, pull the dirt out, and send the clean water back to the head of the plant so that we don't waste any of that water. When you first put the filter back online, an interesting phenomenon is that some of that stuff that's been suspended settles back in. So for the first minute or two of your new filter operation, the water's not as clean as it could be. So we have a series of valves and piping set up here to do what we call filter to waste. And we take some of that first initial water coming back through the system, and we back siphon it out and dump it back into our recycle tanks. All of these are air actuated valves, very precisely controlled. Okay, so we're now down inside the chemical room, and in the course of water treatment, you need to use certain chemicals as part of that process. The 3 principal chemicals we used, and they'll be stored in these large polypropylene tanks, is we use polyaluminum chloride, which is an aluminum-based compound that helps to aggregate the algae to float to the surface in the DAF. At the end of the plant, after we've filtered all the water, we still have to add some chlorine. For that, we use sodium hypochlorite. And then lastly, we like to pH adjust the water so that it's slightly a basic solution. And that means that if you have metal pipes in your house, there's a very low to minimal probability that you would leach any of the copper or solder off of your interior piping. We've got electrical systems going into place. We've got the chemical metering pumps and the chemical control devices all wiring in. A little bit messy down here, but again, we're doing a lot of work. We have a lot of people in place. We're actually filming during lunchtime because if we tried to film during the middle of the afternoon, there'd probably be 4 or 5 people working in this space, and it'd be hard to film and get around with all the noise they have. I hope you've learned a little bit more about how the project's coming together. I'm excited to have been part of this. We've had some great folks working on it, a great team, and we continue to work up to, in March, having water available to the system because we'll have proved it all out in February. Thank you very much for watching. We started this project about 20 months ago, and we'll have it up and running in about another 4 months, all in the time frame of the original contract duration. It's a $46 million job. Last time we were out here looking at the project in August, a lot of this building was coming together with the brick and the block, but there weren't lights, We didn't have equipment. And now we're to the point where we have electricity, we have gas, we have lights, we have piping, and we're beginning the slow, methodical process of testing all of the equipment. I want to let you know that this is a project that we take seriously, and we've got a great team on it. Over 100 years ago, in 1898, the town built their first water treatment facility, and that building still stands at the opposite end of the pond. Back then, the first chief operator, the first person that held the position I'm holding now, he got a nice perk. He got a building to live in next to the pump station. And he would get up in the morning and get his horse from the stable and ride his horse down to Quissit. And he would look in the pond down there, the reservoir as they called it, and see how much water was in it. And then he would ride his horse back to the pump station and would shovel coal into the boilers to make steam, to fire up the steam engines so they could pump steam, use the steam engines to pump the reservoir full. And the end of his day would be to ride his horse back to Quissit and make sure the reservoir was full before he went to sleep at night. Things have advanced quite a bit. We use electricity for pumping now, and I don't have a horse, I have a car. But the commitment to the folks in Falmouth to build the best possible water treatment plant, to provide the best possible water to the people of Falmouth, is a commitment that's endured for over 100 years, and we're proud to be serving you on this valuable and important project.